Welcome back. So now let's find the rate of change from an equation. And this is, of course, a nonlinear function, right? Because it's quadratic, right? And that's not linear. So here we're given an interval. When you're given an interval like that, that's not an x and a y, it's not a single point. You're always given x. You find y or f of x, right? So those are two x values. You can use synthetic substitution, which is just like synthetic division, to evaluate polynomial functions, or you can substitute into the equation. Let's do both just so you can see. And so, by the way, synthetic substitution only works for polynomials. All right, so now when x is -3, right, so the -3 goes on the outside, and then we put all of the coefficients, we list all the coefficients, and then we can follow the steps for synthetic substitution. All right, so we have x to the fourth, the coefficient is 1, plus 2x, that's a cube, 2x cubed, the coefficient is 2. Notice there's no squared term, so you can't just leave it off, you got to put a 0 there. And then minus x minus 1, so the coefficient is -1, and then the constant's -1. Right? So now it's just like synthetic division. So bring down the first one. 1 times -3 is -3, add. 2 plus -3 is -1. -1 times -3 is 3, add, we get 3. 3 times -3 is -9, add, we get -10. -10 times -3 is +30, and add, we get 29. So that means that f of -3 is 29. Right? And so that's the point, -3, 29. Let's find, now we need when x is -2, right? So do the same thing, right? And the coefficients, 1, 2, 0, -1, -1. Right? So we bring down the 1. 1 times -2 is -2. Add, we get 0. 0 times -2 is not 0. Yes, 0. What am I saying? Okay. 1 times, bring down the 1. 1 times -2 is -2. Add, we get 0. 0 times -2 is 0. I was writing the right thing, but not saying the right thing. Add, we get 0. 0 times -2 is 0. Add, we get -1. -1 times -2 is 2. Add, we get 1. So f of -2 equals 1. So that means that -2, 1 is a point. All right, so now if we didn't want to use synthetic substitution, we could just substitute into the equation. All right, and so then we would have f of -3, and that would be -3 to the fourth power plus 2 times -3 cubed minus a -3 minus 1. All right, so a little bit more computation. I kind of like the synthetic substitution, but the choice is yours. -3 cubed would be a +81 plus, all right, so -3 to the fourth power is +81. -3 cubed is -27. There's minus a negative, so that's +3, and then -1. So that would be 81, and then 2 times -27, that would be 54. So 81 minus 54 plus 3 minus 1. Right, so 81, and you got to add and subtract left to right. 81 minus 54 would be 27. 27 plus 3 is 30. 30 minus 1 is 29. So you see we get the same thing. I just think it's a little more work. I'm going to have to plug in because I got to think all the numbers. And I got to do the computation. Whereas here we were just bring down, multiply, add. Not too difficult. All right, so now f of -2 would be -2 to the fourth power plus 2 times -2 cubed minus a -2 minus 1. So -2 to the fourth power would be +16. -2 cubed is -8, so plus 2 times -8. And then plus 2 minus 1. So 18, that would be 16 minus 16 plus 2 minus 1. So 16 minus 16 is 0. 0 plus 2 is 2. 2 minus 1 is 1. Then I don't have any space, so I'll just put the equals 1 right up there. All right, so you see you get the exact same thing either way. But now let's find the average rate of change. So average rate of change, and this is the only one where I'm going to calculate it out two different ways. All right, average rate of change is the change in the value of the function over the change in the x values. All right, so here's our 2 points. So change in the value of the function is change in y. So average rate of change is 29 minus 1 over negative 3 minus a negative 2. So that would be 28. Negative 3 plus 2 is negative 1. So that would be negative 28 is the average rate of change. Okay, and that's all there is to this one. Let's do one more that's polynomial, and we're not going to do it two different ways. All right, so find the average rate of change for the function. All right, so same function actually, just a different interval. All right, so we have 2 points. Right, so when x equals negative 1, right, so negative 1 goes on the outside, and then it's x to the 4th plus 2x cubed. There's no x squared, so we'll put a 0 there, minus x minus 1. So this would be 1, 2, 0, negative 1, negative 1. Bring down the 1. 1 times negative 1 is negative 1. Add, we get 1. 1 times negative 1 is negative 1. Add, we get negative 1. Negative 1 times negative 1 is 1. Add, we get 0. And 0 times negative 1 is 0. Add, we get negative 1. So this is the point, negative 1, negative 1. In other words, f of negative 1 equals negative 1. So you plug in negative 1, you get negative 1. When x equals 0 is so easy, we don't need to plug in. Right? We don't need to do anything. So if x is 0, all of those things, all those terms with 0, with x's in them, is going to be 0, leaving only the negative 1. So when x is 0, we have f of 0 is negative 1. So we have the point 0, negative 1. So now let's find the average rate of change, which is the difference in the value of the function divided by the difference in the x coordinates. So that would be, right, so we have, I'll start with this one, negative 1 minus a negative 1 over negative 1 minus 0. Well, that'd be negative 1 plus 1, which is 0, over negative 1, which is 0. Right, so that makes sense, right? Because they have the exact same y values, the average rate of change would be 0. Let's do another one. All right, so find the average rate of change for y equals log base 3 of x from x equals 1 to x equals 27. When you evaluate log, remember you're finding exponents. All right, so we have y equals log base 3 of x. All right, so when x equals 1. All right, so that means y equals log base 3 of 1. So in other words, 3 to what power is equal to 1? All right, well, that means 3 to the 0 power, right, would equal 1, so y has to be 0. So f of 1 is 0, right? So when x is 1, y is 0. Right? Let's evaluate the other one, right? So we have now when x equals 27. Right? So that means that y equals log base 3 of 27. So that means 3 to what power is 27? Well, 3 cubed is 27, and so that means that f of 27 is 3. All right, so these are the results, 1 and 27. And when we evaluate log, we're finding the exponent. Now that we have the 2 points, right, we have this one here is the same as 1, 0. We plug in 1, we get 0. This one here is 27, 3. We plug in 27, we get 3. We can find the average rate of change, which is the difference in the value of the function over the difference in the x values. All right, so that's going to be 3 minus 0 over 27 minus 1. So that's 3 over 26. Right, so log functions grow really slow, and the greater the x value, the slower it grows. All right, so there we have found the average rate of change. And I think I've got one more, and then in the next video we'll look at finding it with some tables. All right, so we're going to find, actually no, some real world problems. We're going to find the average rate of change for y equals 2 to the x, from x equals 0 to x equals 4. All right, so f of 0 would be 2 to the 0, which is 1. F of 4 would be 2 to the 4, which is 16. So log functions, we're solving for the exponent. Exponential functions, we're plugging in for the exponent. All right, so now we can find the average rate of change. All right, so we have the points 0, 1, and 4, 16. So average rate of change is the difference in the value of the function divided by the difference in the x values. So that would be 16 minus 1 divided by 4 minus 0. And so that would be 15/4. So whereas log functions grow slow, exponential functions grow quickly, and they grow faster over time, unlike log functions which grow slower over time. And I'm just going to double check, and I think the next one is a real world in a table. So I'm going to end this video, and I'm going to do one more video with real world problems. Thanks for watching. Bye for now.